So what are nanosponges? These are microscopic nanoparticles. They have a tiny void like that you can capture just like a sponge. Then you can capture the drug molecule entrapped in the voids, and then you can effectively target those specific areas. Go to the next slide. So these are having a oocyte. Skip it to the next one. Skip. So what? Wait. Previous. Okay, fine. As we will improve the viability, the main motive solubility, as well as we can improve the residence time, and we can target both hydrophilic as well as lipophilic drugs. So fabric nanosponges are fabricated for oral, parenteral as well as topical application. So I have targeted topical hydrogel, where we have made a polymer. We can use a polymer that is Carbapos 94. What is the rationale behind my study? As I have already discussed, solubility improvement, target effective area. So, sponges that can overcome these drawbacks of the convolution. Go ahead. These is my aim. I will directly go to the preparation part, characterization and antifungal and stability study. Go to the next one. These are the observed parameter, amorphous part of ketoconazole, melting point, and the log P value. Ketoconazole is a class 2 drug, low solubility, high permeability, high log P value, and T half is less than 2.5. So it's effective for a class 2 drug, so that we can formulate another formulation. Go ahead. This is the solubility. Poor active solubility we see. Go ahead. These are the FTI parameters for studying the compatibility. Go ahead. Calibration curve of my drug, that is ketoconazole, HCl is the water. Next. Okay. We'll go to the simple part, that is how we prepare a nanosponge and optimize, then how will we characterize, and then finally the result and comparison. Go to the next part. Okay. My method is emulsion solvent diffusion method. As this first state, I infuse with lemongrass oil, and the drug is ketoconazole, and the polymer I have taken is thiocellulose, okay, and both are taken in an interface. Then it is probe-sonicate, as I have already spoken about scaling to the nanoscience. So it is probe-sonicate into intervals of 5 minutes. Then it is entered into a PPA containing an internal phase, which is dissolved in volume water using an injection needle. Then DCM is evaporated to dry nanosponges, and it is filtered into the allotments of the paper. The nanosponges are collected, and then it is stored in a desiccator for the further analysis. Go ahead. Ketoconazole I've already spoken about. These are the 12 formulations which we have prepared. What we will study here, what is the effect of several variables, that is drug to polymer ratio, that is thiocellulose to ketoconazole ratio. What is the effect of starting speed? What is the effect of internal phase volume on different variables, and how it will affect the entrapment efficiency, particle size, zeta potential, and the viscosity. So what is the need to formulate a nanosponges into a topical formulation, that is a gel. Go ahead. Okay. These are the particle sizes of my various formulations. Go ahead. Wait. This is my optimized formulation. How it is optimized? Go ahead. Wait. Go ahead. The low PDI value indicates the uniformity in particle size. I have said about that 1.09 to 208 nanometer. It is zeta potential, it is particle size is showing. Then solid viscosity index is showing, indicating that the nano size of size distribution is less. The zeta potential value, it indicates my preferred dispersion is of colloidal nature. Then what is the effect? As we increase the polymer ratio from 50 to 300 in the formulation part, the particle size decreases because at lower polymer concentration and high drug ratio, the polymer available to encapsulate the drug is less. So as a result, small size nanosponges form. What is the effect of starting speed? As we have increased the starting speed from 1000 rpm, we have used a magnetic see from formulation F6 to F12, the entrapment efficiency with increase in speed will decrease because the polymer will get adhered to the sides of the container. That is why there is a decrease in the yield, so entrapment efficiency automatically decreases. As we increase the internal volume from 10 ml to 15 ml, that is dichloromethane, the viscosity of the formulation this decreases. So after analyzing these 3-4 parameters, we have optimized one formulation, that is F6. Then we have gone for the in vitro drug release. My results suggested that there is decrease in the calcium concentration, the drug coordination increase. When we move from formulation F1 to F6, that is moving from polymer concentration of 50 to 250 mg to 50 to 300 mg. When the study speed using BCM was 1000 rpm, it showed cumulative drug that is correlated at 76.41% and 71 respectively after 24 hours. But when we increase the study speed from 1000 rpm to 1500 rpm, the percentage cumulative drug release showed this values respectively. I'll go to the antifungal part. Final. Move skip to the next one. Wait. Ma'am, 2 slides, then last one. Just skip to the part. Previous. Okay. As we have optimized the final formulation, that is F6, we have prepared the topical formulation, that is gel using a carbohydrate base, having a pH value and a vitro drug release. And my formulation after stability study, accelerated stability study as per the ICH guidelines suggested more stability and refrigerated next slide. These are the antifungal reported formulations. As we can see, we have measured the zone of inhibition. Move to the next one. Conclusion. What we have overcome and what are the conclusion? Prepared nanosponges were able to overcome the drawbacks of the conventional medication and show improved viability. And there is promising result in entrapment efficiency, particle size, and vitro formation and release. The stability study stages